Okay, students. Now, we have already discussed the self-inductance of a long solenoid. I told you it was a very important discussion. Very much it is asked in the examinations also. I just tell you, we are almost coming towards the end of this electromagnetic induction, right? Because after that we have to discuss AC also, alternating current. That is also attached to this unit. Anyway, we shall discuss it. But before that, our next discussion is a very important discussion. It is the transformer. Look, I want to discuss transformer. Transformer is asked as a full question. It's an electrical machine. All of us are familiar with the transformer. All of us have heard the name of transformer. सबों को पता है ट्रांसफार्मर क्या होता है. तो ट्रांसफार्मर I think all of us know. So let us now today discuss regarding the transformer. First of all, I just tell you, transformer is a device with the help of which we can change the input voltage. That means the input voltage which we are getting, that can be changed. Changed with either it can be raised or it can be lowered. It can be increased or it can be decreased. Okay, so with the help of the transformer we can increase or decrease the voltage. The whatever input voltage we are getting, that can be increased or decreased with the help of the transformer. Okay, this transformer works on the principle of mutual induction. Once I remember you the mutual induction, in case of the mutual induction, the current changes in the primary coil. The current changes in the primary coil, due to which the flux through the primary coil changes, and that change in the flux links the secondary. That is called mutual induction. I hope I have told you, I have discussed mutual induction in the last class and you have understood it very clearly. So mutual induction is that phenomenon with the help of which when the current in the primary coil changes, that links the secondary, alright, and due to which an induced current and hence an induced EMF is set up in the secondary coil. This thing happens in a transformer also. First of all, let us see the construction of a transformer. What happens in a transformer? In a transformer, there is a laminated iron core. I just make it very clear. What is the laminated iron core? Actually, it is a solid thing. If I consider, look, if I consider an iron lamina, okay, if I consider an iron lamina made up of iron of this shape, look, a lamina made up of iron of this shape. It is hollow. This is iron. You just visualize if such type of the lamina means plate. If such type of the plates, a number of plates are placed just one after the another. If such type of the plates, a number of the plates are arranged one after the another, then what type of the structure we shall get? We shall get this type of structure. This structure is known as the laminated iron core. Alright? It's the laminated iron core. One side of the laminated iron core here, on which there is the winding of the insulated copper wire, which acts as the primary coil P. P stands for, I told you before also, it is called the primary coil. And it is connected to the AC source. This is the symbol for the AC source. You know, circle, and within this S, alphabet S is written. That is input. It is the AC source. So we have kept an input AC source inside, like this. This is an input AC source, followed, and which is to be changed. This is the input which is to be changed. that, so this winding on the left side, on the left face, here see the winding of the insulated copper wire is the primary connected to the input AC source, and just in front of this face, another face, the front face, on that there is the windings of the again insulated copper wire, that is the secondary coil. Okay, it is connected with RL, it is the secondary coil, and it is here, look, RL is what? It is a high resistance, it is called the load resistance. You know, it is called load resistance. A high resistance called load resistance. इसको कहाँ लगाते हैं? सेकेंडरी में लगाते हैं. प्राइमरी में मैंने लगाया इनपुट एसी और सेकेंडरी में मैंने लगाया ये लोड रेजिस्टेंस, जैसा कि फिगर में दिखाया गया है. और मुझे जो इनपुट, जो आउटपुट मिलेगा वो कहां से मिलेगा? यहां से. दिस इज द आउटपुट आई एम गेटिंग फ्रॉम हियर. ओके, वेरी क्लियर. नाउ दिस इज रिगार्डिंग द कंस्ट्रक्शन of it. Now let us come to the working. What happens in the working process? When input AC is fed, we are feeding the input AC through the primary, then what will happen? In the primary, there is a current will be changed, fluctuating current. Current will be changed in the primary. When the current through the primary will be changed, then what will happen? If the current through the primary will be changed, then the flux change will be noticed. The flux change will take place in that primary. And that change of the flux, like this, look, that change of the flux will link the secondary in this way. ये क्या होगा? इसमें से फ्लक्स चेंज करेगा, और ये प्राइमरी और सेकेंडरी इतनी नजदीक है कि इसका जो फ्लक्स चेंज होगा प्राइमरी में वो चला जाएगा किसमें? सेकेंडरी में. वो फ्लक्स चेंज सेकेंडरी में जाएगा. यानी दैट चेंज ऑफ द फ्लक्स विल लिंक द सेकेंडरी एज ए होल. थियोरेटिकली हम लोग मान के चलेंगे एज ए होल, पूरा जा रहा है उसमें. दिस हैपेंस. देन व्हाट विल हैपन? Obviously, change in the flux will be linking the secondary coil, due to which an induced current and an induced EMF will be set up across the secondary, जो कि मुझे आउटपुट के फॉर्म में मिलेगा, which is obtained in the form of the output. I hope you have understood it, what I have said. I said that the change in flux through the change in current through the primary will be occurring due to this AC source. Due to this AC source, that change in the current will produce the change in the flux through the primary, which will link that in the secondary. Secondary में वो flux का change link करेगा, जिसके चलते secondary में क्या होगा? Secondary में एक induced current and hence an induced EMF will be set up, and that is obtained from the output. Actually, this thing is happening. Then what will happen? Obviously, change in flux यहाँ भी हो रहा है, यहाँ भी हो रहा है. तो by Faraday's law, definitely Faraday's law of electromagnetic induction. By Faraday's law of electromagnetic induction, what will happen? Induced EMFs in primary and secondary coils are. By Faraday's law, induced EMFs in the primary and the secondary coil are. क्या होगा? यहाँ लिखेंगे, तुम्हें याद होगा, that is E is equal to minus d phi by dt. मैं यहाँ लिखूंगा EP is equal to minus NP d phi B by dt, and ES is equal to minus NS d phi B by dt, or better we write d phi p by dt and d phi s by dt. एक बार चेक कर लो, देखो मैंने क्या लिखा, EP EMF induced in the primary coil, that should be equal to minus NP. NP is the number of turns. D phi P, rate of change of flux in the primary coil. D phi P stands for primary. Here ES is equal to minus NS into d phi S by dt. यहाँ पर d phi P by dt and d phi S by dt, these are the rate of change of flux in the primary, rate of change of flux in the secondary. And what are NP and NS? These are number of turns in primary and secondary coils respectively. ये हो गया number of turns in the primary and secondary coils respectively. I hope you all are getting it. Then what will happen? इतना होने के बाद अब यहाँ पर क्या होगा? अब देखो इसमें क्या होगा. यहाँ पर हम लोग मान लेते हैं whatever flux is linking the primary, the same flux linking is taking place in the secondary, because we have said that the whatever flux change is taking in primary, the same is happening in the secondary. That means here what happens? D phi P by dt is equal to d phi S by dt. Okay, so ES by EP is equal to NS by NP. Look, चूंकि मैंने कहा कि जितना फ्लक्स प्राइमरी में लिंक कर रहा है एज ए होल उतना ही सेकेंडरी में लिंक करेगा, इसलिए रेट ऑफ चेंज ऑफ फ्लक्स इन द प्राइमरी शुड बी इक्वल टू द रेट ऑफ चेंज ऑफ फ्लक्स इन द सेकेंडरी. कमेंट के साथ. तो क्या मिला हमें? ES by EP is equal to NS by NP. Okay, I am coming to the remaining parts in the next video lecture.